Okay, so let's talk a little bit about the sklearn homework. So I got some questions about this, and I think it's because it was not immediately obvious to folks which data set to use for their train test split primarily. And so let's talk through it and kind of see if I can clarify some of the questions. All right, so I gave you all of this sort of header. So I loaded a train data set and I loaded a test data set. So if we look at the train.info, you can see here I have a column called survived, which is what we're trying to predict. And so if we look at the data set here, you see survived is a 1 or a 0. So a 0, they did not survive. A 1, they did. If we look at the test.info, though, you'll see there is no survived column. And this is, I think, where the confusion was. So this data set is actually from a Kaggle competition. So these are data samples from a Kaggle competition that actually you make your predictions, you train a model, and you submit it, and they score your model's performance. And so in this case, the train data set is what we use for our model training and selection. And so we actually have to split that data set. The test data set is what we use to make predictions to upload to Kaggle, which we're not doing at this stage yet. And so I think folks got confused because they were trying to use both of those rather than splitting here down above. And so my apologies that the instructions apparently did not make that sufficiently clear. So what I'm going to do is I'm going to walk through what I did for this pre-processing just a little bit, and then I'll walk through the pieces that I was asking you to do. So here what I've done is I've filled all the nulls in the embarked column, and I've selected 5 columns to be my numeric features and 2 columns to be my categorical. And so I've only selected 2, whereas there are actually a couple more. Obviously there's name. I chose not to use that because that would have resulted in basically, one unique value for every one of the passengers, presumably, which would probably not be realistic to put into production, right? And then same for ticket, because this looked like it was just kind of junk data and also didn't seem to be that useful. And so what you'll find is if a column has a lot of unique values, where most or all of the data is unique, it's not very good to use. And so we're just usually eliminate that. So in this case, you can see I've only used things that had a few unique values, and you could see that if you looked at the data yourself. I've already done all that binarizing, which basically does the one-hot encoding that we talked about, which you don't need to worry about for the purposes of the midterm. And then I embedded a lot of this in code that's sufficiently impenetrable. But basically, I did all of my imputing to fill in the missing values. And then I scaled the data, and I appended that to the passenger sex, where I binarized it. And so I basically, in one shot here, processed some of my columns, and then I added it to the scaled numeric columns, and did it for the same for the test. That's right. So this is the train, and basically I did all my pre-processing here in kind of one line, and appended this binarization of the embarked column. So again, for the midterm, I would provide this just like I talked through in the study guide video I've uploaded for the midterm, just like I attempted to do here. I reshape it just so it's the proper shape, which basically means it's not a bunch of really long values, but it's one row with 10 features for you to use. So the intent, and I realized I should have just pretty much discarded the test data for the time being, but the intent was for you to basically come down here and finish the machine learning workflow. So you have to set y train equal to survived, and so let's just go ahead and do that. So in this case, I actually have to go back to the training data and take the survived column and set it equal to y. So let's actually just do y train equals train survived. Again, if you remember, if I try to do this for test, I'll get an error because it doesn't exist in test. I only know the answer for the records in the training data set. Let's insert some more new columns, and let's just do that. All right, so I've done that. Set y train equal to the survived column of the data set. You'll notice the train data set doesn't include this information, sorry, the test data set, which means we need to do a train test split of the data from the training data set so we can evaluate the accuracy. So I need to use the training data set to do the train test split. All right, so split the data into xtrain and xvalidation. And so because test is already used, but test doesn't actually have the answers, I'm going to go ahead and create train x validation y train y validation equals train test split on this right here, xtrain. And usually you wouldn't. Usually you would be doing it off of this pre-split data set, but like I said, in this case, xtest does not have the answer, right? So I can't assess the accuracy on the test data because the survived column is not there, right? Kaggle has not given that to me. And so what I have to do is take my training data set and split it one more time, right, into train and validation. You could have called these whatever you wanted to. Validation is just the convention. You could have called this x test, y test, and it would have been fine. I would have accepted that. But basically, at the end of the day, all you have to do is split the data set into training and validation. And we'll use the validation just like we usually would use test. But again, in this case, the test data set doesn't include the answers. And I need to do that for the y value as well. So I'm going to fit two types of class algorithms, a decision tree and a support vector classifier. So let's go ahead and initialize the decision tree. So let's take CLF equals decision tree, initialize it with the defaults. Let's erase this. So CLF equals decision tree classifier. I'm going to do CLF dot fit because fit is how we test the model. It's how we train the model, right? So fit is how it learns from the data set. So I'm going to do fit on y train and x train and y train, right? And so this is the model. It's going and it's learning from the data. And let's go ahead and insert some more cells above, insert above, right? Okay, very good. Let's just delete all these too while we're at it. Edit, delete cells. All right, so I've fit the model. So I've taken the data set, I've split it, I've initialized my model, and then I've fit the model. And now I need to fit the other type of model. So SVC, so SVC, CLF. You could call this whatever you wanted to. There's not a right answer, but you do have to initialize the model. So here I've initialized it to SVC CLF, and I'm going to fit it also on the X train and Y train. There we go. And now it doesn't actually require it. It just says to fit them. And here we go. Need to train each algorithm and print the mean absolute error for each. All right. So by default, since this is a classification, we actually get the mean. We actually get the mean accuracy. So like, let's just look at the score. So we've got a fit, and let's look at the score for CLF dot tab score x test y test. Oh yeah. So I did validation. All right. You got to be consistent. X validation. That's the only problem with using validation. It's much longer to type out. X validation, Y validation. All right, so I'm 56% accurate, right? SVC score X validation, Y validation. So you can see here my support vector classifier is more accurate because obviously higher is better. A higher accuracy is better. But since I asked you to, let's go ahead and do the mean absolute error. So since that's not the default metric for scoring, because again, this is classification, mean absolute error doesn't necessarily make a ton of sense as a metric, we're going to do it ourselves. So what I'm going to do is I'm going to use the predict. So CLF.predict, and you can see here what I'm going to pass it is I could do a prediction on either of the X, right? I could do X train, and what it'll do is it'll give me all the predictions. These are all of its guesses for every record of the training data, right? So it's guessing that the first 2 passengers survived, the next 3 did not, the next one did. So these are all the model's guesses. These are its predictions. But since it already knows the training data set, presumably the accuracy would be higher, right? Actually, let's go ahead and look at that. Train guesses equals. All right, so I've made guesses for the training data. Let's look at the average error. What is that? Accuracy score. I already imported it for train guesses and Y train. And so you can see I'm 85% accurate on the training data, right? But if I do this for X validation and Y validation, did I get that right? X validation, there it goes. I'm only 56% accurate. So you saw that from the data that the model has already seen, it's actually much more accurate than the data it hasn't, which is why we do this train test split in the first place. But anyway, so this is the accuracy score for the validation data. So I've taken the X validation, I've made my predictions, and I've added them to this variable called train guesses. And I've done the accuracy score on train guesses and the Y validation. And this is actually usually how you'd assess your model. But I asked you to do the mean absolute error, which is just this right here. And so this is just the mean absolute difference between the guesses and the actual data for the classifier. And so that is, yeah, for each. So I need to do this for both of the models. So let's do SVC predictions equals SVC.predict. Oh, sorry, what did I call it? SVC CLF.predict, and then the X validation. All right, and then mean absolute error, SVC predictions, and then Y validation. And so my absolute error for that one is 0.41. So in this case, lower would be better because absolute error is how incorrect I am. So in this case, this is actually pretty much just the inverse of my accuracy score. All right, so that is it for the homework. And so I think the confusion wasn't so much the content, wasn't so much the key concepts. I think most people seem to get it. It was really just which data set do you use, and so that's my fault for not making it more obvious. The midterm, you will not have to worry about X train and X test and which do you use. I'll provide you an X and a Y. Right, I'll provide you an X and a Y, and you will take the X and split it, and so it would look more like this, right? And so that would be probably more obvious to folks, right? Is if I just provide you one data set that I've already done some pre-processing for, you take that data set and you do a train test split, right? But in this case, the things to know are how to do a train test split, how to initialize your classifiers or your models, fit them, get a score for them, and then this is how you would do a manual score, right? How do you make predictions and then score them yourself? That's this right here. And so as you can see, just like with the midterm, I wouldn't expect you to find these, the mean absolute error and the accuracy score that you saw me working with, I imported right here. And so I will provide those to you for the midterm, and I already provided you these solutions. So I hope that's helpful. If you have any questions, after viewing this video and the study guide, let me know.